All right, now on to question number 4. And question number 4, it gives us a function. It says that g of x is equal to e to the 3x plus 1. So g of x is equal to e to the 3x plus 1. Let's hear what they have to say now. And they say that obtain a Maclaurin series expansion for g of x up to x to the 4. So to obtain a Maclaurin series expansion, first thing we're going to need is we need to differentiate this. So first thing, find what is g of 0. All right, so g of 0 is going to be equal to e to the 0 plus 1, which is e to the 1. So g of 0 is e to the 0 plus 1, which is just e. That's g of 0, just e. Then we need to find g prime of x. G prime of x is going to be equal to, when you differentiate 3x plus 1, you get 3. So that is 3 times e to the 3x plus 1. And so then that means that g prime of 0 is equal to 3e. It's equal to 3e. Then we need to find g double prime. G double prime of x is going to be equal to, we differentiate this now and we're going to get 9e to the 3x plus 1. And so what does that mean? That means that g double prime of 0 is equal to, plug in 0, we're going to get 9e. This doesn't look bad. And so now g triple prime of 0, g triple prime of x first, is going to be 27e to the 3x plus 1. So that means that g triple prime of 0 is equal to 27e. And finally, we needed to find g quadruple of 0. Well, find x first. And that's going to be 27 times 3. I think that's 81. So that's 81 e to the 3x plus 1. It's 81 e to the 3x plus 1. Right. So that is telling us that then g to the 4th of 0 is equal to, now 81 times e to the 3 times 0 is 0 plus 1. So let's get 81e, 27e. So what does that mean now? That means that using Maclaurin series expansion, we know that g of x is going to be equal to, it's equal to g of 0. It's g of 0 plus g prime of 0 times x. G prime of 0 times x plus g double prime of 0 times x squared over 2. G double prime of 0 times x squared over 2 plus g triple prime, I'm going to write it as g3 of 0 times x cubed over 3 factorial, and 3 factorial is 6, plus g to the 4 plus g to the 4 over 4 factorial. 4 factorial is 24 times x cubed, x to the 4, sorry. Right? So it's g to the 4 of 0 times x to the 4 over 24. This looks messy. Let's fix this. G to the 4 of 0, x to the 4. Nice. So now let's plug in these now. So g of x is equal to g of 0. G of 0 is e plus g prime is 3e times x, which is 3xe plus g double prime of 0 over 2, which is 9xe, 9xe over 2, 9x squared e over 2, because this is 9e, 9e over 2, yeah, plus g triple prime of 0, which is 27, so that's 27 x cubed, 27 x cubed e over 6, 27 x cubed e over 6, plus g to the 4, which is 81e to the 4 over 24, 81 x to the 4 e over 24. That is g of x. Now you may want to simplify it. I don't know, maybe you want to. Let's say you wanted to simplify it. Let's simplify it up here. All right, maybe you want to simplify it. I don't know, depends on you. And just if you want to, I'll simplify it with you. So simplifying it, we can write that g of x is equal to, as you notice, all of them have e, so we can factor out e. We're going to get e times 1 plus 3x plus 9x squared over 2, 9x squared over 2 plus 27 over 6 can be simplified. So 9 over 2, that's 9 over 2 x cubed, 9 over 2 x cubed plus, now 81 over 4, 81 over 24 can be simplified to be 27 over 8, 27 over 8 x to the 4 plus 27 x to the 4 over 8. That's if you want to simplify it that way. Doesn't matter to me. That's g of x. All right, I know it's kind of squint, so let me try to fix right here. Nine x cubed over 2 plus 27 x to the 4 over 8. That looks a little. All right, now that we finished that, now it says hence estimate g of 0.2 to 3 decimal places. So g of 0.2 is just going to be equal to, you're going to substitute x as 0.2 in the function here. So it's going to be e times 1 plus 3 times 0.2 plus 9 over 2 times 0.2 squared plus 9 over 2 times 0.2 cube plus, you're going to put in finally now, that was what, 27 over 8? 27 over 8, 0.2 to the 4. 27 over 8, 0.2 to the 4. All right, nice and easy. So let's work out as a g of 0.2. So working that out, we have 1 plus 3 times 0.2 plus 9 over 2 times 0.2 square plus 9 over 2 times 0.2 cube plus 27 over 8 times 0.2 raised to the 4th power, and we multiply that by e. My final answer is 4.95. So I got 4.95. You want it to 3 decimal place, so it's 4.951. All right, just to check to see if we were right, this is our estimate. What you can do to check if you're right is work out what was g of x, e to the, so check to see if e to the 3 times 0.2 plus 1, check to see if that gives you the same thing. So you can just check that. If you get the same thing, you know you're correct. So 3 times 0.2 plus 1 is 1.6, e to the 1.6. Yes, they are correct. When you work that out, you get your 4.95. So no, so correct. All right, so this is just a check. All right, this is just checking to see if the absolute value is the same as our approximation. All right, so this is a check. This is just a check. Always good to check your answer. Nice. Now part B. Part B says, let f of x be equal to x minus 3 sine x. Part B. So they give us that f of x is equal to x minus 3 sine x minus 1. That is f of x. Cool. Now it says use intermediate value theorem to show that there has at least one root between minus 2 and 0. So first thing we can find is f of minus 2. F of minus 2 and f of minus 2 is equal to minus 2 minus 3 sine minus 2 minus 1. That will equal to minus 2 minus 3 sine minus 2 minus 1. That's equal to negative 0. Negative 0. That looks like negative 0.27. That is, of course, less than 0. So let's try to find out what is f of 0. F of 0 is equal to 0 minus the minus 3 sine 0 minus 1, but that is equal to negative 1, which is less than 0. So that gives us no indication if there's a root between minus 2 and 0. So let's try to bisect them and try maybe a number like 1. Try f of 1. So now f of 1, which is between 0 and 2, is 1 minus 3 sine 1 minus 1. So 1 minus 3 sine 1 minus 1. That's no good either. That's giving us a negative value. That's negative 2.52. So let's bisect 1 and try a number like a half. Maybe a half will work. All right, so let's try a half. When we try a half now, we get that f of a half is 0.5 minus 3 sine 0.5 minus 1. Let's try a quarter. Try a quarter. 0.25 minus 3 times the sine of 0.25 minus 1. 1.5. Oh, wait, I can't try 1. 1 is bigger than 0. My apologies. I needed to try minus 1. I was wondering why that wasn't working. Try minus 1. Yes, so this should be minus 1 minus 3 sine minus 1 minus 1. I was wondering how that was looking that way. So now we can try that minus 1 minus 3 sine minus 1 minus 1. That's 0.52. So this is correct. 0.52, and that is greater than 0. All right, and so since f of minus 2 is greater, since f of minus 2 is less than 0, and f of minus 1 is greater than 0, and minus 1, you can tell them, and minus 1, of course, is between minus 2 and 0, and f of x is a continuous function on the interval minus 2, 0, hence f of x has a root on the interval minus 2, 0. All right, that's the conclusion. Nice and easy, soft. All right, hence it has a root on the interval. Nice. Let's look at the next part of the question now. It says, use at least 3 iteration method to show that f of minus 0.538 is approximately 0 on the interval minus 0.7, 0.3. All right, so we're going to be using bisection method. So using the bisection method, I like to do it in the form of a table. It's easier for me when I put it in the form of a table. Using 3 iterations, so I'm going to use 3 iterations. I like to start with, this is AN, this is BN, then I find the midpoint M, then I find f of the midpoint. All right, nice and easy. We're using 3 iterations. All right, call this A, B, AN, BN, the midpoint M, this is f of the midpoint. All right, and just to write down back what was f of x, remember f of x is equal to x minus 3 sine x minus 1. And the values that they gave us to start with are, I think it's minus 0.7, minus 0.7, and minus 0.3. Now, if you find the midpoint of those two, minus 0.7 plus minus 0.3 divided by 0.2 is negative 0.5. Then what is f of negative 0.5? You plug that up here and you're going to get negative 0.5 minus 3 sine negative 0.5 minus 1, and that is giving me negative 0.06. All right, nice and easy. Now, since it is negative, which is good, using 3 bisection, then that means that it falls on the interval. First, we need to check which one of these was negative. All right, so we needed to check which one is negative. So if you were to write down what was f of negative 0.7, just write down that. Just checking if that one was negative. Negative 0.7 minus 3 sine negative 0.7 minus 1. This one is positive. Right, so this one is positive, and this one is negative. This one is positive, and f of negative 0.3, f of negative 0.3 is negative. And so what that means is we can eliminate this 0.5 now. All right, so now we're actually in between 0.5 and 0.3. So we're gonna write now that we're between 0.3 and negative 0.5. All right, now we're going to take the midpoint of those two, negative 0.3 plus negative 0.5 divided by 2, that's negative 0.4. All right, find out what is f of negative 0.4. So you have negative 0.4 minus 3 sine negative 0.4 minus 1, which is negative 0.23. All right, now f of, we know that this one, we know that the midpoint lies between this and this, and we know that f of this is negative. And so now what that means is that the root lies between negative 0.3 and negative 0.4. So let's continue. So the root lies now between negative 0.3 and negative 0.4. All right. Wait, let me see that. No, that's saying that the root lies between this is where the root lies. The root lies okay. Let's look at the second part. It says use at least 3 iterations of this interval bisection to show that f of minus 0.38 lies between minus 0.7 and 0.3. Okay, let's do that. So again, first let's write down what is f of x. So f of x is minus f of x is x minus 3 sine x minus 1. And remember, we said that f of negative 0.7, put that in a calculator. F of negative 0.7, negative 0.7 minus 3 sine negative 0.7 minus 1. That's 0.23, which is greater than 0. And f of negative 0.3, that's going to be equal to negative 0.3 minus 3 sine negative 0.3 minus 1. That's equal to negative 0.41, which is less than 0. So now using the bisection method, bisecting that, we would get that the midpoint between those two is equal to negative 0.3 plus negative 0.7 all of that divided by 2 is equal to negative 0.5, I believe. Let me check that to make sure. Negative 0.7 plus negative 0.3 divided by 2 is negative 0.5. So now f of negative 0.5, that's going to be equal to, plug it in negative 0.5, plug in negative 0.5, that's negative 0.5 minus 3 sine negative 0.5 minus 1, that's equal to negative 0.06, which is less than 0. So from the first bisection, we're getting that the root lies now between, minus 0.5 and minus 0.7 from the first bisection. That's what we're getting. All right. So now let's bisect that part now again. So m is equal to now the midpoint of negative 0.5 plus negative 0.7. We divide that by 2. What we're getting is negative 0.5 plus negative 0.7 divided by 2. That's negative 0.6. Now let's find what is f of negative 0.6. F of negative 0.6, we plug that into the function, we get negative 0.6 minus 3 sine negative 0.6 minus 1, and that's giving us 0.09, which is greater than 0. And so which one was less than 0? As we can see, the root therefore lies between. So using the second bisection, the root lies on negative 0.5 and negative 0.6. So now we need to bisect that again now. So m is equal to bisect that minus 0.6 plus minus 0.5 divided by 2, we get negative 0.55. And so find what is f of negative 0.55 from the bisection. That's equal to negative 0.55 minus 3 times the sine of negative 0.55 minus 1, which is equal to 0.018, which is greater than 0. And so from the third bisection, root lies on minus 0.5, comma, minus 0.55. All right. Good. All right. And so the midpoint of that now, the midpoint would be equal to minus 0.5 plus minus 0.55 divided by 2, which is minus 0.525. And so f of minus 0.525, that would be equal to all right, so you plug that in now, minus 3 times that minus 1, I am getting 0.05. And so, did I do that right? No, I didn't do that right. Let me check that again. 0.525, that minus 3 times the sine of that minus 1 is minus 0.021, which is less than 0. And so the root lies on minus 0.525, comma, minus 0.55. And so if you take the bisection of that, the midpoint would be minus 0.525 plus minus 0.55 divided by 2. And now you get your minus 0.5. Minus 0.5 0.538, right? And f of minus 0.538, that's going to be equal to, you plug that up there, you plug it up there, minus 0.538 minus 3 sine minus 0.538 minus 1. You put that in a calculator, minus 0.538 minus 3 times that minus 1, and you get 0.0076, or 0.076, that's what you're getting, minus 0.538 minus 3 times that, minus 3 times the sine of that, minus 1. Oh no, minus 0.00741, and this is approximately 0. So we can write that this is now approximately 0. All right, and so that is shown using the bisection method. All right, so we can say hence minus 0.538 is an approximated root of f of x using the bisection method. So that's that. Nice and easy, soft. All right. Now let's look at the last part of this. It says use the Newton-Raphson method with estimate x1 being 5.5, approximate g of x, where g of x is sine 3x on the interval 5, 6. So the next part, it gives us a function g of x, and it says g of x is equal to sine 3x. So first thing, remember it said the first approximated root, it said the first approximation is 5.5. All right, so first thing we need to do is find what is g of 5.5. G of 5.5 is equal to the sine of 3 times 5.5, which is equal to g of sine of 3 times 5.5, that's minus 0.711785. So that's g of 5.5. Next thing we need is the derivative g prime of x. G prime of x is equal to, when you differentiate sine, you get cos. You get 3 cos 3x. So now we need g prime of 5.5. G prime of 5.5 is 3 times the cosine of 3 times 5.5. We put that in a calculator. 3 times the cos of 3 times 5.5. And I'm getting that's equal to minus 2.10719. So that's g of minus 5.5. Nice and easy, soft. All right. So now what does Newton-Raphson formula state? Newton-Raphson formula tells us that the second approximation x2 is going to be equal to x1 minus g of x1 over g prime of x1. All right, this is Newton approximation. But we already work it out, right? We already work it out. So it's going to be x1, which we found x1 they told us was 5.5, minus g of x1, which is minus negative 0.711785. that is being divided by g prime of x1, and g prime of x1 we found that to be negative 2.10719. So you put all of that in a calculator, that will give you the second approximated root. Right, so I put that in my calculator. I'm going to get 5.5 minus, divide those part, minus 0.711785 divided by minus 2.10719. That's 0.337788. And so 5.5 minus that is 5. So I'll just write the final answer. The final answer, when I put all of it in my calculator, is 5.162. And how much decimal place it wanted it to? 2 decimal place, so it's 5.16. That's the second approximated root. Right? Nice and easy, soft. And that takes care of module 2. So let's go to module 3. All right, question number 5. Question number 5 says, Alicia's chance of getting to school depends on the weather. The weather can either be rainy